Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark, and this is episode number 10. So we are now in double figures. Whilst 10 episodes doesn't sound too much, it is nearly 10 hours of content already. And don't worry, it's not me babbling on for 10 hours, as that would be pretty boring. Most of it is the awesome guests we've had on, and today is certainly no exception. In the last episode, we were joined by Simon Painter, talking about functional programming in C#. And whilst this podcast isn't language or platform specific, it is perhaps slightly biased towards .NET, because that is the language I develop on, and it's awesome too. So it would be a bit remiss of me to have an episode on functional programming in C#, which is a .NET language, and not also have an episode on F#, which is .NET's functional programming language. And I could be wrong, one of our guests will correct me, but I assume functional is what the F in F# stands for, and this is going to be the topic of today's episode. So I am really excited to have another group episode today, because these are always great fun. And today I am joined by three guests: Ian Russell, Isaac Abraham, and Scott Vlashin. So let's do the same as our last guest episode and go around the virtual table and let everyone say hello and give a quick introduction. So first up, we have Ian Russell, software developer specializing in F# and domain-driven design. When I first met Ian, I was attending one of his talks on F# at one of the DDD conferences many years ago. DDD is in developer, not domain-driven design. Check out episode 6 if you want to know more about the DDD conferences. I remember watching Ian's talk. Obviously, I learned some F#, but I was also quite pleased seeing that he was using the LinkPad for one of his F# demos. Anyone who knows me knows I'm a huge fan of LinkPad. So very cool that you can do F# with it. So massive welcome to the show, Ian.
Thank you, Dan. So, I'm Ian. I've been developing for 25 years, something like that. .NET since 2003, and F# officially actually writing code in production since about 2017. I work for a company called Software Park. We're a remote-first software house based in the beautiful city of Vienna in Austria. Sadly, I work in the not-so-beautiful place of Coventry, but it's a nice enough place. I've been talking about F# since about 2013, and I concentrate primarily on beginners or new people to F#.
That's good, because I'm definitely a beginner. So next up we have Isaac Abraham, F# MVP, .NET and Azure consultant, and author of the Get Programming with F# book, which we will link in the show notes. And we'll certainly touch more upon that in this episode. So welcome, Isaac. Great to have you on.
Hello. Great to be here. So just adding on to what you just said. So I'm the founder of Compositional IT. We're an F# and Azure consultancy. So we do training and coaching in F# and Azure. We do outsourced development. We're also, especially now, given the whole COVID thing, mostly remote organization. I would say that our office is mostly based in London, although I'm based in Germany. I've been here for probably 4 or 5 years. Been working in F# on and off for probably 5 or 6 years. Been in .NET almost all my career, which normally when I say I've been doing it for nearly 20 years now, I feel like the oldest in the room. But actually, I think in this case, I'm probably the more junior one compared to Ian and Scott.
Yeah, I think you're beating me with .NET. I think I've been about 15 years, and the rest has been C and C++. I'm probably the youngest in that case. And last but certainly not least, we have Scott Vlashin, author of the website fsharpforfunandprofit.com, which is a fantastic and free resource for learning F# and functional programming, and also author of the book Domain Modeling Made Functional. So welcome, Scott. Thank you for joining us.
Thanks very much. Thanks for having me. I think I've probably been programming longer than most people. I started programming in the late 1980s. I started doing .NET when it came out in 2002, 2003, but I've actually had a lot of experience with lots of other languages, and I think that gives you a kind of different perspective. I think a lot of people who've grown up with only one language think that's the only way of doing things. So that would be something to talk about later on, actually, is the effect that learning, Smalltalk and Prolog and Python and all the other ones have on how you approach statically typed languages.
Definitely. There's so many different languages, and I wish I had more time to play with them all, but I definitely need to find time. I think it's quite important. So thank you everyone for the introductions. For my part, I'm a C# developer. I've played a little bit with F#, but haven't really built anything with it. So I'm going to be that newbie asking dumb questions. I'm guessing, though, that a lot of the listeners are perhaps similar to me, used to using either C# or a similar language, but curious about F#. I'm personally finding that as I've been writing more functional code in C#, especially with the newer versions of the language having more functional syntax, that I'm feeling a vast quality improvement in my code by doing so. So this has made me even more interested in giving something like F# a go. But before we talk about F# specifically, maybe for those that missed the last episode on functional programming in C#, maybe we can start with what functional programming actually means and what benefits it gives us.
Start with the hard one.
Isaac.
Me?
well volunteered, Isaac.
Yeah, thank you, Scott. Thanks for that. I guess it's as controversial a question as if you ask someone what is OOP as well. You probably get 10 different answers. I guess I can talk from what I think of it as. I guess it's really 2 or 3 different kind of attributes in the way you program. Probably one of the things is the separation of data and behavior. So one of the fundamental things in OO is that you tend to have classes with some sort of encapsulated state and some methods. You call a method and it will do something to that internal state that you don't really see. And one of the things we tend to do in F# is to move away from that and say we've got data, which you can see, and you've got functions. And you give these data to functions, and these functions give you back different versions of data. So that's probably one of the first things. And then sort of goes hand in hand with that is this notion of immutable data. So the idea that once you've got some data, you can't change it. It's fixed for life, but you can make copies of it with changes applied to those copies. So in an example, sort of I just said, you might have something like an order, and then you might have a function which is complete order. And what that wouldn't do is take in an order and then just change the flag of the status to complete, but it will give you back a new version of that order with the status changed to complete. And there's all sorts of sort of effects of working in that way, which I'm sure we'll talk about later on. And I guess the third thing I'd say is this notion of expressions as opposed to statements. And I think in C#, I didn't really ever have a good understanding of the distinction between them because it blurs the lines, I think, between both expressions and statements. But in F# it's quite clear in that everything's an expression. And what that means is everything you do has a result. You can't have really a void function or a void method. There's no real idea of that. You call a function and you'll get something back. Even if that something is, there's nothing actually of interest, that will actually be a result as well that you can reason about and do something with. And that applies all the way down the language. So we don't have if-then statements. You have if-then expressions where every branch returns a value, almost like, I guess, switch expressions in newer versions of C#. Everything works like that. And those kind of 2 things, that immutability in expressions and the separation of data, to me, those, in my experience, are kind of the core things of functional programming. And if you sort of adhere to those 2 or 3 things, everything else sort of naturally just falls into line into sort of functional programming, I think.
Yeah, you can definitely see, like in the later versions of C#, where they're definitely veering towards expressions with like expression body members, as you mentioned, switch expressions. And then I really like when you start putting them all together and you start making your method more functional, how suddenly, okay, I can turn this method into an expression body member and get rid of the return, get rid of the braces. It just becomes so much cleaner. It's really nice.
Yeah, so I have something to add, which is that a lot of people, I think of features, like if you have a lambda or if you have a switch expression or if you have, immutable data. I mean, these are the kind of building blocks, but when you put them all together, the whole is bigger than the sum of the parts, which is you start thinking about coding in a different way. And that's the stuff that's not at all obvious. I mean, you say, well, C# has these things or other languages have these things. Does that, they have these features, but the way you put them together, it starts changing the way you write code. And as you say, it starts creeping, and all of a sudden you start writing code in a very, very different way from object-oriented code. And that's not at all obvious because that's not a syntax thing. That's not something that kind of you can see. But as you get more and more experience, it completely changes the way you write code. And I think that's an interesting thing that people kind of go through as they get more and more into it.
Yeah, the hardest thing about going to a functional language from a non-functional language is the thought process. It's a completely different way of thinking about writing code. And that's, if you've done OOP for a long time, it's very hard to turn all that off.
Yeah, I guess from a C# developer, I know they said .NET developer, but obviously that covers all the languages. But from a C# developer, if you're used to using LINQ, that initial mindset shift when you started moving to LINQ, I guess it's kind of like just taking that but much further. And it feels very, very LINQ-like, where you start chaining stuff together.
Plus, you've got to look at it as they're adding more functional features to C#, but it's not fundamentally a functional language. So often you don't get the full benefit of the features as they're added to a non-functional language, whereas if you add them to a functional language, you get the full benefit. So some things like pattern matching, they look quite nice, and people think, well, they're slightly better than switch statements, etc. But they're far more powerful than that. And if you move into a functional language like F#, there are a whole load of things that you can do that you just can't do in C# because it wasn't a functional language to begin with.
And that reminds me of when object-oriented programming, because I lived through object-oriented programming going through the same hype cycle that functional programming did. Like in the mid-90s, object-oriented programming was the trendy thing. And so people added object-oriented programming to everything. So you had object-oriented COBOL, and object-oriented Fortran, and it's like, because they're focusing on the features. And, object-oriented COBOL with object-oriented features is not the same as an object-oriented language. It's never going to be Smalltalk, no matter how many features you add to it. And I think it's the same thing. The features are nice, but it's the sum of the parts, is the overall philosophy of how you write a program is very, very different. And that's like I said, it's more than just the features.
Yeah, I'll just add on two more bits to that. I think two ways that that might manifest itself is both the defaults of the language. So that's, again, going back to things like immutability, whereas in F# everything is immutable by default, and in C# at the moment, the majority of things are kind of mutable by default, with some extensions now with things like records, where you can sort of get immutable sort of data structures. But also, I think the other thing that is often overlooked, and this sort of is the inverse almost of what Scott touched on, it's the features that aren't in the language that often tell you the most about it. So if you look at like F#, it doesn't have protected, and it doesn't allow you to do void, and it makes it difficult to do mutation. And a lot of things like that are kind of almost push you down the road of it's much, much easier to adopt a functional style in F# simply because that's what it's optimized for. I think C# have taken an interesting approach, which is very different, which is more of almost a Scala style approach with let's try and merge and sort of blend kind of existing OO features and these kind of functional features into one, and come with this nice sort of blend where you can sort of pick and mix the bits and use them interoperably. Where I think in F# it's a more cleaner separation. You've got sort of the OO side on one half, mostly for interop, and then you've got the FP side on the other half, which is what you spend probably 95% of the time in.
I suppose part of it for me with all the new features in C# is what's the correct way to write code? In F# it's clear, it's functional first, whereas in C# it's very much, is it because it's a new feature that's what you should use? Or is it perfectly good to stay with OOP?
And to follow up on that, I mean, for people who've been programming in C# since it first came out, I mean, async is a good example. There's 4 or 5 different ways of doing async, and there's, as it's evolved, there's all these different kind of collection libraries and stuff. And the problem is, every time you add a new thing, you still have to support the old thing. So if you're supporting legacy C# code, you have to understand 4 or 5 different ways of doing something. And so if as a language designer, I think it's quite tricky to add new features, because it ends up making the language more complicated. All the different interactions between all the different possible ways of doing something, I think it does get tricky after a while.
How have you found that, Dan, given your blog post recently as well?
Well, it's funny. I was actually just going to mention that, like following on from what Ian said about what's the right way of doing things. And that blog post you mentioned, where basically it was, and I can include this in the show notes, and I think I mentioned it in the last episode too, it was about making C# more succinct, basically writing more functional code. And in the replies, but like on Twitter, in the blog itself, and on Reddit, there was definitely 2 camps. There was the people that were more interested in functional programming, and they were saying, yes, they completely agree. And I know, Isaac, we had lots of conversations on the back of this blog post. But then there was the more object-oriented developers that were replying saying, no, they found even just like there was one reply which was talking about the very first example in the blog post, which was just LINQ. And he was saying, no, that's not readable at all. And I found that really interesting because that wasn't doing anything new and shiny.
To be fair, I've had situations where I've written stuff in a slightly imperative way, and then ReSharp has come up and said, I can rewrite that as LINQ. And it's you've said, okay, do that. It's rewritten as LINQ, and I've looked at it and I've thought, what?
I've had to undo, but I've definitely had examples of that. But the example at the top of the blog post was just it wasn't nested LINQ or subqueries. It was just very basic LINQ.
Scala is a language where it has a very strong dichotomy between because it supports both paradigms, OO and FP. There's in the language community, there's a very strong dichotomy between the OO Scala people who are basically using Scala like a nicer version of Java, and the functional Scala people who use it as like a Haskell. And it causes a lot of problems if you're trying to like maintain other people's code, and you're an OO person, you're trying to maintain this weird Scala code that you can't understand what you're doing, what people are doing. And so it's interesting. If I was writing, for example, C# code, I wouldn't use some of the weird LINQ things like aggregate, for example, which is quite a tricky thing to understand in LINQ. And I probably would not use that in C# code. I would try and make my C# code understandable to people who are, have that kind of certain level of experience. On the other hand, if I was writing F# code, the F# equivalent of aggregate is called fold, and I would totally use that in F# code because the F# community, I would expect that an F# person would understand what I was doing. And so, if I was doing C# code, I would not write weird functional stuff because I just don't think that's idiomatic for C#. It's very hard for other people to maintain.
I've been doing a bit more JavaScript lately, and it's interesting how actually that's quite functional in the sense of like using reduce quite a lot, where you mentioned. Then obviously for a lot of languages, you've got like the RX extensions, which are on .NET and JavaScript, and lots of other languages as well. And it's interesting how it's not just C# that's trying to move towards a more functional style. Even front-end languages like React, which is a UI framework, is trying to be very functional.
Yeah, absolutely. I was just going to say, actually, Scott, it's funny you mentioned that aggregate because I can actually attest to that in the real world. Probably the last full-time C# job I had some years ago, I was almost known as the guy that wrote the weird C#. And I'd written kind of a LINQ query, and it ended with an aggregate. And they just couldn't. The rest of the team were like, "This is not C# that we can understand." And it's interesting. Often when I see people say, I'm kind of nervous about adopting F# because people on the rest of the team might not understand it. That might be true, but it's not about the syntax is one thing. But to be honest, you get over that within a day or two. The lack of curly braces and forget about semicolons and stuff. The real challenge is the way you write code. And if you were to write pure functional code in C#, I think it would be just as difficult to understand for the average C# developer, if not more difficult, than it would be to do it in, than an equivalent sort of either an F# solution or an OO sort of focused C# solution. And the other point I'd touch on, Scott, in terms of the sort of splitting community, I would just add that there is, I would say within F#, you've got probably a greater degree of uniformity. Most people adopt a kind of a similar way of designing solutions. But I would say in the F# community, there is a kind of a split. I wouldn't say it's a big one, but you do have on the fringes people that would like to see F# become a bit more Haskell-like with certain features like type classes and things which F# doesn't have. And I'd be surprised if it does actually ever get them. It's kind of functional language, but it doesn't go off the rails with like crazy features in the sense of type classes or higher kinds or dependent types and things like that. It's actually, I still think it's mostly a set of simple fundamental rules that once you get your head around them, the rest sort of naturally just bleeds out. At least that's my findings.
Yeah, and I agree. You were talking about what F# doesn't have, and I totally agree about things, people always talk about features, but things which you can't do are just as important as the things you can do. And not having some of the Haskell features, I actually think is a really good thing for F#, because F# is not Haskell. If you want to do Haskell, write Haskell. But the fact that you can't do certain weird things in F#, I actually think is a big plus for the language, because it means that I can pretty much understand anybody's code in F#. I don't have to be an expert in some weird category theory thing to look at people's code and understand it. And I think that's a big plus. Yeah.
Is it worth, whilst we've been talking about syntax, taking a step back a bit, and if we assume that a lot of listeners haven't even seen the F# syntax, and for me as someone that's new to F#, things that jump out to me are things like there's no curly braces or semicolons, which Isaac mentioned before. And to be honest, personally, we all indent our code using whatever language. So for me, it kind of feels like the curly braces are kind of redundant, even in C#. I know it's hard in an audible podcast, but what does F# look like if you're used to using something like C# or C++ or any of these C-type languages?
Well, the most interesting thing, or the most difficult thing that people find is the fact that it's top-down. You write the smaller bits of code at the top, and then the most the bigger things fit at the bottom. So it's very different to C# in how you structure it. But it works not just in the file, but also from within the project as well. So it's a bit like JavaScript. You can't use it until you set it up. Whereas in C#, the code can go anywhere.
So does that mean that the order of files in the project is going to be in a specific order, or does that not matter?
It is. Yeah, the code's got to be. You've got to create the code before you use it.
I think Scott did a lengthy blog post on sort of an analysis of this. One of the things you get by this is you can't do circular dependencies. So you can't have spaghetti code in the sense of, A references B, which references C, which references A. You just can't have that in F#. So the initial instinct of everyone is always to recoil at this. But actually the flip side of it is, if ever you want to understand how something works, it's just look up the file or look up the project. It's never you're going to be jumping up and then down and then up and then down. It's always just follow it upwards and then you get to where you end up needing to go, sort of thing. But I think, Scott, you did some huge sort of analysis on, was it Entity Framework or something?
Yeah, I did. And so, I mean, this is like in C# you have a tool like ndepend to try and help you find dependencies. And in C# code, your files are organized alphabetically. And so if you come to a new C# project, it's not very clear where you need to start, But in F# project, the top file is always the basic one, and the bottom one is always the main program. And so you literally cannot have some low-level code, call the main top-level code, because they have to be in a certain order. And so you can't, this is a thing that stops you doing something. You cannot have circular dependencies or cyclic dependencies. I actually did a comparison of some F# code and some C# code, and the C# code most C# code is full of circular dependencies because there's nothing stopping you doing it. But when it comes time to refactor, these following these dependencies around, this class depends on this class, which depends on this class, which depends on this class, which depends on the first class. It makes it hard to do kind of refactoring, extracting a method or something, because there's all these dependencies and they're all connected. So you basically end up with not having any kind of layering. And the classic software design technique is to have layers. You have the one, and each layer is decoupled from the layer above it. You don't know about the people who call you, right? And that's like a fundamental principle. And F# sort of enforces that, and C# doesn't, which is a shame.
I'd probably only add on that C# you do have it at the kind of the component level. So you can't do circular references at projects, but it doesn't go any further than that downwards.
Yeah, the assembly, you can't have a circular thing in assemblies. Two assemblies can't depend on each other. And that's a good thing, because otherwise it'd be a mess, right? Which assembly do you compile first? And in fact, in my blog post, apparently there was a circular dependency back in .NET 2.0, and it caused nightmares for them. So yeah, I think it's something you don't even realize how important it is until you see the benefits of it.
So one of the other benefits is the fact that it compiles as you go. Because of the way the compiler works, it's you don't have to physically go out and compile it. It's doing it as you go along, and it's just a case of making sure your types match. So you're looking all the time at function signatures, So if you look in a product, if you look in something like VS Code or Rider, you'll often see the function. You'll also see the function signature as well. And we sort of concentrate on those things. And once they all match up, the thing basically works. It's odd. You'll do a bit of refactoring, and as long as everything compiles, you run it and it just works. It obviously doesn't always, but it's a nice thing a lot of the time.
So speaking of types, I'm aware of this, but I've not done enough F# to actually really appreciate the power of this. But from what I've read initially, it sounds like you don't need to specify types anywhere near as much as you would in a language like C#, and it infers a lot for you.
But it's still strongly typed. So it is inferring, but it's still strongly typed. It's not dynamic or anything like that.
That sounds insanely powerful, and also kind of not scary, but from where I'm used to specifying types. I think that would probably be one of the things I would struggle with initially. I think just trusting it to get the right type.
The compiler's really good. I mean, it basically works on usage. So it works on how you use it, and it works backwards from there to work out what the types are. It's really clever.
Yeah, it basically, if you you think of like a record, and you want to access a field on a record, the compiler will basically say, right, you've tried to access the field name. Are there any types in scope that have a field called name? And if there's only one, then it must be that one. Therefore, this type must be customer, for example. So it works surprisingly well. Certainly there was a kind of skepticism when I first started using like F# with the type inference, because it just seemed almost too good to be true. But it's like 99% of the time, it just works. And it really makes refactoring a huge amount easier, because you don't have this situation where you change something at the bottom and then you have to change 5 functions, signatures, or methods to return the type that you've changed to. It just naturally sort of figures it out, basically. And it's kind of scary when it works, which is, like I said, nearly always. And one other thing it does on this type inference thing, it will also infer if your functions can be generic without you even sort of specifying it, which sometimes makes you think a bit differently about what your code actually does.
Another feature I really like is, I think they call it pipelining. Is that right? Where you've got the pipe and the greater than symbol.
That's a forward pipe.
Yeah.
Yeah, there's a backward pipe, and there are other forward pipes and backward pipes as well with multiple parameters.
Don't use them.
I didn't know there was backwards pipes.
Yeah.
We don't talk about those.
Don Simon says don't use them.
But basically, yes, there's a pipeline, yeah.
So if I explain my basic understanding of a forward pipe, so thinking about PowerShell or Bash, where you've got a script and you've got one command and then you have a pipe symbol, and then you would chain the output of one into the input of the next. From what I understand, it's similar to that.
Yeah, it's exactly the same.
But rather than a pipe, it's a pipe and a greater than. And then, am I right that it takes the output and that's the last function parameter of the next one?
Correct. Yes. Yeah. So it's a bit like the opposite of link. So with link, you've got an extension method, and the first thing is the thing that you pass along the line. With pipelining, it's the last thing that gets passed along the line.
I see. I use ligatures in my font as well, so it converts the pipe and greater than sign to almost like a triangle shape, which is like an arrow,
yeah.
which makes it look really nice as well. But it does, from a C# developer, it does feel very link-like, where I can take a bunch of methods and just chain them together into a chain of functionality.
So Scott does a lot of videos on this sort of thing, not particularly forward piping, but composition. So this is one of the big things that F# has. So being able to compose bigger types and bigger functions out of smaller types and smaller functions.
Yeah, I was gonna say, it's like, if you like how link works, imagine being able to do that for anything in any part of your program without having to add a whole bunch of extension methods. So, I mean, people who like link, they like it a lot, and it's like, but that only works for collections. So if you can use the link approach, where you dot in and you just keep chaining methods one after another, in F# you get that sort of for free. You don't have to do any extra work. You don't have to write extension methods. You don't have to do any of that. It just that's the language is kind of built around that way of working. So that's a really appealing. Once you get used to that way of working, it's really, really nice. Yeah.
This is something that last year at some point I sent a tweet out basically saying, I really wish you could do like the link stuff on a single object rather than a collection. And we actually spoke about this in the last episode with Simon Painter. And a few people replied and said, well, why would you want to do that? And then so I'll find the tweet and put it in the show notes. But I put a reply, which was a code snippet. And by not being able to do it, I had to declare a local variable because I was reusing that multiple times. And in the code snippet, by doing link on a single object, I could turn the whole method into an expression body member. It suddenly became much smaller and cleaner, and I would argue easier to understand. And unless I had come across that example, I wouldn't have realized that that would be useful to be able to do link on a single object until I actually saw it and thought, oh, that's really powerful.
Exactly.
The way I try and describe sort of this pipelining to C# devs is just imagine that you didn't have to, if you wanted to make an extension method, you've got to make it static in a static class, and you've got to put the this keyword in the first argument. Imagine you didn't have to do that. And it would just make a method, and it implicitly is sort of extensible on another one, on another type. Then that's basically what it is. That's really all pipelining is, except instead of dot, you have the arrows, that vertical pipe in the arrow. That's all it really is. But it fits in the whole link sort of functional thing. It wouldn't really work with, like, if you had mutable data, it's not quite as nice, and so on and so forth. But yeah, that's really all it is.
So I'm curious. I know you said don't do this, but what is backwards pipelining, and how does it fit in? If you've got, can you do forwards and backwards in the same?
Yes. Yeah. So basically, if you had something that you forward pipe into a function, that gets applied as the last one. But then if you have a backwards pipe, that gets applied as the last one at the end of it. So it goes forward pipe first, and then the backwards pipe afterwards. But don't do it. It's confusing. One of the great things about F# is most of the code that you read is perfectly readable. As soon as you start having lots of funky characters in there, it starts to get difficult. So I look at C# code now, and I see all these Elvis operators and everything else, and I get really confused. Whereas I look at F#, and there are very few of those sorts of things, but F# was always the language that had all these funky characters. But there aren't any. Well, there are very few.
Well, I guess with C# and the Elvis operators, that probably leads on to another point about nullability. Up until recently, most things can be null. Where in F#, am I right that F# is by default not null?
For any types that you declare yourself, yes. But if you're interoperating with like the BCL, so strings and classes from everywhere else, then it doesn't sort of take part in that. But if you declare your own sort of records and things, then yeah, everything will be sort of non-nullable, and then you have to put in extra keywords to say this is actually nullable.
We try and avoid using null. Null is considered this is a difference between C# and F#. In C#, null is perfectly fine. In F#, null is like a code smell, and if you see null in a piece of code, that's normally considered like, why are you doing that? There must be a very important reason, like interrupt or something, where you're doing it. But you really, really try and avoid null in F# code.
So the obvious next question is, what do we use instead? So if you can't use null, we have something called the option type. And the option type is we're covering discriminated unions without covering discriminated unions here. So an option type is either it's something with a value or it's none. So it's a bit like a nullable type in C#, but you can apply it to anything. So not just nullable types.
Yeah, it works for ints and strings. It doesn't have for, like, nullable types only work for things like ints. In
the last episode with Simon Painter, we were talking about, we spoke about the option type and maybes and eithers and getting that into C#, and even like talking about trying to describe what a monad is, which sounds like pretty much this. But you get this, like, obviously with C#, you need to like write those extension methods yourself to handle that, or use a library. I think he mentioned, I can't remember the name of it now. It's in the show notes from the last episode anyway. But in F#, this is just built in.
It is, yes.
And further than being built in, I would just say in F# you don't have special cases so much. Like in C# you have a whole bunch of stuff specially for null, like the Elvis operators. Like in F#, the way you handle chaining option types together is not a special case that's hard-coded into the compiler. It's a feature that you can actually use for anything, not just options. So that the way you handle chaining options is the same way you handle chaining asyncs or the same way you handle chaining, all sorts of other things. It's the same technique that's a generic technique rather than a specific special case for null.
I think that's a good point you made there, Scott, which is more about the different approaches. Like F# has this notion of let's try and find general solutions that we can use everywhere. They may not be highly optimized for any specific case. Like you're not going to have language extensions with custom operators to deal with options or results or something, but it's a general pattern. Once you know it in one place, you can use it everywhere. I think in C# they've taken a different approach, which is let's really optimize around things like async await. You've got custom keywords for that. Nullability now, you've got, Elvis and the null coalesce and like 3 or 4 other ones designed specifically around nullability. But I could imagine what will we do in C# 10 or something if we got result type? Are we going to need then similar operators for that, or will we not have anything or something else? I don't know. But I think that's kind of an interesting one, is that C# has taken an approach of let's put in extra sort of keywords to really make it easy to do these specific cases. But if you want to do something outside of that, it maybe is not as easy, or you have to figure it out yourself or do something else.
So, Ian, you mentioned something called discriminated unions before.
I did, yes.
That's very well volunteered.
Yes. Okay. So discriminated unions, describing them to a C# dev is difficult. They're a choice type. Say, for instance, you had we'll take the option. It's either there is data, or there isn't data. So it has to be one or the other. It's a bit like an enum, but it's not, because you can have data against some of the case types and not data against others. And it can be different types of data against different choices. So it's not like an enum, although it sort of looks like one. But it's also not like a class hierarchy either. If you compile a discriminated union in IL, what you get is a class hierarchy. But it's not a class hierarchy because it's a closed set. So if you add a new item to the list, anyway you do pattern matching on that discriminated union, it will tell you you're not covering all the cases. Whereas if you've got an abstract type and classes that you derive from it, you can add one to your heart's content, and the compiler will never tell you there's a problem. So it's like the opposite of object-oriented programming in many ways, because you're interested in the data that's not shared. You're interested in the data that belongs to each of the cases. It's quite a difficult thing to explain. It's much easier to see. Once you see it, it's like, oh yeah, well, that's fairly obvious. But it's quite hard to explain in terms that for people that don't understand or have never seen it.
It sounds very similar to where with type inference, how, as I mentioned before, I understand it, but then I probably want to appreciate the power until I start using it. I'm guessing this is very similar, where once you start using it, you can't imagine not having it.
Yes. Well, when you try and model something in a non-functional language that doesn't have them, it's very hard, because you're always thinking, well, that would be great for a discriminated union.
A good example, maybe, Dan, would be something like, imagine you've got a customer, and a customer can be contacted in one of 3 ways, like email, telephone, or post. And you wanted to model the idea that the telephone's got a telephone number, post has got an address, and email's got an email address. How would you model that in C# in an OO world today? And there's sort of 4 or 5 different ways that you see, but none of them I found are really satisfying, because you could you'll end up with sort of making all the fields nullable on a single record, and just make sure you never touch the wrong ones when, if it's post, then never touch the telephone number. Or you end up using inheritance in a class hierarchy, which, to be fair, most people tend not to do because it just feels too heavyweight. And that's kind of that area that discriminated unions kind of fit and solve.
So your first example there, where you've got things that could be null, and then you might want to put that into a database and use something like Entity Framework to map a POCO object to a database schema which does support nullable columns. How would that then map into using? And this probably leads on to another question I was going to ask a bit later about how well F# plays with frameworks like Entity Framework or ASP.NET, but maybe we can touch on that later. But does it map quite well? Does a discriminate union, would that unravel itself almost?
It would be the same issue so you have with inheritance in OO. So you've got normally 2 strategies for dealing with that in relational databases. One is you put them all in one table and you just make all the columns nullable. and then you have a discriminator column that says this is this subtype sort of thing. Or you take a table per subtype approach, where you have like the common fields in a table, and then each union case would have their own table with just their fields in them, and then you sort of link the two together. And that's the same way that you do inheritance in OOTable. I think EF actually supports both approaches. So it's actually not that different. It's just more at the code level how you reason about it.
That's actually a really good example, like visualizing it in, because I think one of the entity framework options is how a hierarchy gets mapped to the table. And I've seen it before where you've actually had a column which says what type it is.
Yeah, that's called a discriminator.
Yeah, that's really helped it click in my head, I think. Hopefully it has for the listeners as well. Isaac, you mentioned at the very start you were talking about things like immutability, and I think you were describing pure functions as well without using the term pure. And I know like C# 9 has these new record types, which makes it a lot easier. Is everything just naturally tend towards being more pure functions? Because I guess like with code, you've always got to at some point write to a database or call another service or have some form of state. How do you actually manage that in a world that's leaning towards pure functions?
It's probably worth mentioning F# doesn't like force you to do purity, and it won't give you any sort of type hints to say, this function is making a database call. You're not allowed to do this. It's not like Haskell, which sort of forces you to have this whole I/O spiel. So let's leave that aside. It's more about, I think, F# gives you some signals to help you sort of know if those functions might be doing something like that. But generally what people tend to try and do is write pure functions to deal with their domain, their data, their transformations. And then at the boundary of the app, just at the edges, that's where you'll go outside to your database call. You'll do your writes, you'll do your reads, you'll maybe make web service calls. But then once you've got your data from these impure parts of the universe, you then just go back into your internal sort of pure domain. And it's more like the ports and adapter style approach there, where you give it some data, do some stuff inside, and then push it out into the outside world again.
Just to add to that, this style of doing software architecture is not specifically functional. I mean, the Onion architecture and the ports and adapters and, domain-driven design has a concept of not caring about the database and so on. Doing this approach to designing your code makes your business logic much easier to test, because you have no external stuff in your pure code. So your business logic is completely deterministic, it's completely predictable, it's super easy to unit test because you don't have any kind of databases mixed up in the middle of it. And so this is just a good style of programming anyway. It just happens that functional programming fits this style really, really well, because that's how functions work as well.
Looking at a lot of Ian Cooper's talks about like the ports and adapters and this kind of thing from a C# world, if you're not used to doing that, it's quite a different way of thinking. Whereas it sounds like if you're doing F#, like a lot of the things we've spoken about so far, you almost force down that route, just not forced down, but it's just a natural path you would take.
The easy path, yeah, it's the same thing we're talking about. Is as developers, we tend to be very lazy, right? And you're just going to do, most of the time, you're going to do what's easiest. So if it's easy to use null, I'm going to use null. But if it's hard to use null, I'm not going to use it. And it's the same thing. If it's easy to have impure functions, I'm just going to probably do that by default, and then I have to refactor them when I want to unit test them or something. But if it's hard, you tend to do kind of the right thing. If it makes it easy to do the right thing and hard to do the wrong thing, and I like a language that does that. I mean, languages that encourage you to do the right thing, I think is a good idea.
Yeah, Don Syme's done a tremendous job with F#. I think it's and then obviously all the guys that are working on the compilers and things. Yeah, It's one of those things, if you feel that you're having to work really hard to solve something, you're probably doing it the wrong way. So it tries to guide you along the correct route. And if it gets difficult, it's telling you shouldn't really be doing this.
Yeah, it feels like where you mentioned before about the order of even the files in the project matters. I can picture that being initially frustrating, but then as the project grows, it will save you lots of time and having maintenance nightmares later down the line.
I'd agree with that.
Yeah, exactly.
So I did mention before about things like Entity Framework and ASP.NET. How well do those things play in the F# world? I know there's something called Giraffe for which is that like ASP.NET but for F#?
Yes. So Giraffe is a thin wrapper around ASP.NET Core, and then there's another one called Saturn, which is a thin wrapper around Giraffe. So Giraffe is basically a functional wrapper. So it takes away a lot of the non-functional usage of ASP.NET Core and makes it much easier to use for us F# developers. And Saturn's just slightly more opinionated.
Well, I was going to say about libraries versus frameworks. I think there's a big difference between libraries and frameworks. A library is something that you're in control of how you call it, and a framework is something that you are forced to adapt to its way of working. And OO design tends to be very framework oriented. You basically have some classes and you're supposed to inherit from these classes in order to get the functionality done. And functional programs really hate frameworks, and they much prefer libraries where you have these tools and you build bigger things from the smaller components, but you are personally always in charge. And I think that's why libraries, we tend to take libraries like ASP.NET, which is a framework, and try and convert it into something like Giraffe, which turns it into a library where you can build things from the smaller things. It's just, again, it's a subtle way of thinking about how you build programs.
To put that in context, maybe for the listeners that are thinking, what does that actually mean in reality? If you think of the old sort of web API world where you make a class that inherits from either controller or something like that, and then you'd make methods on the class and decorate it with things like, this is for this route, and then this is the handler sort of thing. In Giraffe, it's a very different way where you basically say, given this route, and don't even bother with classes or anything, just say, given this route, which is maybe it's the raw string, pipe it into this function. And this function is going to give me back some data, and I'm going to pipe it into another one. And then at the very end of this chain, I'm going to then wrap it into an HTTP response. And it's almost like if you look at ASP.NET with the pipelines, it's almost like everything works like that. Not just the sort of the cross-cutting concerns, but everything you do. It's just a chain of given some message, do something with it, give back an async response, and then wrap it in HTTP sort of thing.
It sounds very similar to, and I know this is not supported anymore, but the Nancy framework. I don't know whether anyone's used that.
Yeah.
Where you'd literally it'd be like a Lambda expression into the function you want to call or the endpoint.
Yeah, exactly. It's
a shame that's not being supported anymore.
Carter exists. That's quite an interesting one. So I have the pleasure of working with Jonathan Channon, and he's still working on that. It looks really good.
So what's that called, that one?
Carter.
Oh, I have heard of that. I've not looked into it though.
Yeah, so it's like a slightly updated Nancy, or it's a Nancy for .NET Core.
Ooh, I'll have to have a look. I'll find that and include a link to that in the show notes.
So going back to the link analogy again, imagine you could write your ASP.NET stuff in the same way that you would write link. Right, the same idea that a request comes in and you feed it to the next thing, we feed it to the next thing, and it comes out as a response at the bottom. So it's exactly the same thing as using link, but with HTTP. So that's how a functional library would work, and that's how Giraffe works, for example.
The funny thing is, if you think about HTTP and web apps, really what they are is functions. You give it some request and you get a response back. There is no real state. The whole thing of HTTP is it's stateless anyway. So in that sense, F# and functional programming in general fits really nicely with that paradigm. You get an HTTP request, you give back a response with a code and some payload. There is just data. So it actually fits really nicely.
But I guess as part of that, most API endpoints would, as part of that, call into a database or another service. So it's not quite that pure. But I get your point, though. It's from just looking at that bit of code. Your point about it being almost like a link statement, that's kind of, even in ASP.NET and C#, that's kind of how a lot of my endpoints are now starting to look with expression body members, where it is just an expression, which might be a bit of link as well, but then that calls into something else, but it's all abstracted away. So it looks like nice and clean from just looking at the controller point of view.
I mean, if you even look at the stuff like David Fowler is doing, or Ben Adams, a lot of what they've been looking at recently is things like how can we get a really pared down sort of ASP.NET core pipeline with just sort of this is my route, map it to this handler sort of thing. And in effect, that's almost what Giraffe does in a sense.
Yeah, I was going to say, just imagine there are no controllers. If there are no controllers, then you're on the way, because controllers are still class-based.
There is no spoon.
Right, you don't need a controller.
Yeah, I think quite often, like I've done, some of the projects I've worked on, I've used Mediator, which there's your handler and your business logic, and quite often the control is literally just calling straight into that Mediator handler or the Mediator pipeline.
Yeah. So Giraffe is effectively that, but instead of calling out to Mediator is the routing system.
Right, nice.
So you throw away all the rest of it.
I know there's the new, is it API? Who wrote it? Audalis. Steve Smith has recently written API endpoints, which I think tries to clean that up in C#. But that's maybe one for another episode, not being F#. We've spoken a lot about things, so we've covered like the type system, pipelining, pattern matching, discriminated unions, null handling, immutability, expressions over statements. Are there any other key things that F# brings to the table that we've not really touched on?
Scripts, maybe? Do you want to talk about that, maybe, Scott? I don't know if you...
Yeah, I mean, well, just one simple thing about the low noise in the syntax. Again, it's not particularly, the fact that there's no curly braces and stuff. I mean, what I like about it is you actually get just a lot more code on the screen. That's something very simple. Like if you're used to using language like Python or something, it's a very compact language, and F# feels to me like Python, but statically typed. And it's just nice that you don't have all this noise on the screen all the time. You can focus on the logic. I mean, that's a trivial. I know it's not the most important thing, but it's kind of a nice little benefit.
How do you decide how to separate out your different files? So, for example, in C#, quite often people would have a file per class. And now with C#9 introducing record types, where I'm trying to use record types more, which is pretty much a one-liner, I'm finding, actually, I don't want one file with one line in there. So it sounds similar like with F#, where you've got lots and lots of functions which aren't encapsulated in a class. How do you decide how to break up those into files or modules or the different elements?
Well, most people tend to put things into modules to begin with, but most people tend to split it into two files per, I'm going to say bounded context, but business area. So you'd have a file for types and a file for functions.
Right. Okay.
And then obviously you have a load of common stuff as well that gets moved up to the top. So you'd have a load of common types and common functions. But basically it is modules. There's namespaces as well, but that's really tied into working together with interoperating with C#.
I mean, in general, just like you organize any code functions that do the same thing live together, and functions that don't, that you group them by what they do. But one particularly nice thing is, unlike classes, it's quite hard sometimes to extract a method for refactoring, right? Extracting a method can be quite tricky. But the nice thing about pure functions is they don't have any dependencies other than the parameters that are passed in. So if you decide that you actually don't think this function should live here and it should live somewhere else instead, you literally just copy and paste it. You don't need to do a complicated extract method or anything like that. It's a lot easier to move things around in F# code. So typically if I was starting, I'd probably put everything in one file, and then as it gets bigger and bigger, I start moving. Okay, this thing should be over here. Let me organize it a bit better, and I can refactor very easily without worrying that I'm going to break things.
That's a really good point, because in C#, when doing refactoring, I'm very dependent on using tooling like ReSharper to adjust the namespaces, to just move stuff around. And that works well, but it sounds like in F# you don't need that. You can literally just move it.
Yeah. Carrying on from that as well, there isn't a ReSharper for F#. You just don't need it. We don't tend to debug that often either. So one thing we haven't mentioned so far is the REPL. And the REPL's really interesting. So the ability, because a lot of what you write is pure functions, the ability just to copy some code and run it in a local runtime in the REPL, the read evaluate print loop, you can just try code out there and then. So you don't have to run a program or anything like that. You don't have to write a test. Just try stuff out, whether it's in a script file or an actual FS file. You can just highlight the code and run it.
So for listeners that haven't heard the term REPL before, this is just like using a command line, effectively, isn't it? So you can just type a command out, hit enter, and it gets evaluated.
Yeah, or just highlight the code in your code base. So the actual code you're writing, you can just run in the REPL.
We mentioned LinkPad at the very, very start, where you can, even in C#, you can just highlight a bit and press F5, but you can't do that in your IDE. So with F#, you can just do that, highlight a bit of code, F5, and boom.
Well, Alt and Enter, but yeah.
So nice.
It is. It's a real game changer. Yeah, if you want to try stuff out.
I was going to say, in some ways, it's even a bit further than LinkPad. I don't know if this is still the case. When I used to use LinkPad, you basically would put your code into the script hit F5 and it would run the script and give you the results. Whereas with F#, you can basically think of it as you keep the state after you execute some code. So you could have a function that's doing something and then just repeatedly call that function with different values and then store that somewhere and then get some other code and try something out. So it's a bit more sort of interactive and dynamic in that regard, that you can just create code and try things out in this REPL environment. And when you're happy with it, yeah, that looks good, I like the way that function is behaving, or the type looks right, then you can copy it into your main sort of FS files, and then it's part of your code base as well. So there's a kind of an exploratory element as well there.
No, that's really nice. You're right, in LinkPad, when you press F5, that's a single run. It doesn't persist any variables or anything. There's a drop down where you can choose whether you're running a single statement, which will just literally dump out the output of that expression. So I shouldn't have said statement, I meant expression, or a list of statements, which is like a script, or you can go into program mode and have classes and functions and all these things. I realised, given I'm in a chat with F# people, I should really be careful about saying the word expression over statements.
We're not zealots.
I know Isaac's picked me up on that a few times over Twitter.
Yeah. So the other really nice thing I like about F# is collections. So we deal with an awful lot of data. We transform a lot of data. We do lots of transformations on the data that we get into different formats and things. And oftentimes you think of, well, this is what I want to do, and most of the time there's a function already there in the collections for you to use, built into the pipelining system we've already got. So you don't have to learn anything new. It's quite magical, really.
Is there any performance issues? Well, because if collections are immutable, I know you can have immutable collections in C# as well, but rather than just appending to a collection, regenerating the whole collection.
Yes, there can be performance issues, but you need to do with a lot of data. But you can still drop down to things like I forgot what it's called now. The
C# list.
Yeah, resize array.
Resize array.
Yeah. If you want performance, you can use the C# classes, but in general, the performance is actually very good if you work with immutable collection in a certain way. It's the thing. If you work in a certain way, it works really well. And if you try and do, for example, trying to do for loops is not particularly efficient. But if you use the map function, which is the same as the link select function, that's pretty performant. And so again, you just have to work with your code in a slightly different way. But in general, there's not really a big performance issue.
We have a few thousand items that we manage most of the time. We might have 5,000 GPS signals to deal with. You wouldn't notice any difference using whichever you use, really.
I'll just add on to that. So there are some sort of things that F# can do as well in terms of trying to make these collections as performant as possible, because if all your data is immutable and you want to add an item onto a list, what you can really do is just say, well, it's the same list as the previous one we had, just with an other item added at the front of it, because nothing can change underneath. So it's actually perfectly safe to keep the old list and not copy all the data across, just reference the existing list. So there are kind of tricks that it can do to try and optimize things like that. But if you do have some tight loop where you're doing, million modifications, you need it to be as performant as possible, then fine, within a function, just within that scope, use a mutable collection or some mutable data, but just don't let it bleed out to the rest of the app. It's kind of just inverts it around and says, yeah, you can use it if you need to, but it should be the exception to the rule as opposed to the other way around.
Yep. The other option as well is if you've got lots of cores, you can use parallel collections. Because all the data is immutable, you can run off and use the parallel versions of the collections.
It's funny, like just before you said that, Ian, and then Isaac, you mentioned about it being safe. That made me think about the talk about immutability and concurrency. Well, I'm sure that we've all been developing for quite a while, so we've all experienced the headaches you can get with concurrent code. Presumably, like writing in a more functional style where you're using pure methods and immutable data makes
Pure functions.
Makes that a lot. Oh, did I say methods? Oh, sorry. Pure functions,
sorry,
that's all right.
A lot of that goes away, yes. It's not a free ride. You still have to think about those sorts of things. But at least at the code level, you don't have to worry about, have you got this lock working over this shared global mutable state?
Yeah, most people when they look at things like F# and it's immutable data, they think, well, how does that work? It can't possibly be efficient, can't possibly work. Actually, it's the benefits that you get from it far outweigh any possible downsides.
Yeah, I can imagine. Even C#, we're used to using strings which are immutable. It's just taking that to the next level.
Exactly.
Yep.
Imagine if strings and dates were mutable. How much extra pain would that cause? That would be really painful. So yeah, I mean, the fact that you can't change them, you can just trust. If I pass a string into a function, I can trust that string's not going to be changed by somebody inside that function doing something stupid. Right? It's really nice to be able to rely on that, and you just trust the code. And imagine that everything was like that.
So, are there any scenarios where you certainly wouldn't use F# over something like C#?
I think this goes back actually to your point before, Dan, about things like entity framework. So there are some libraries that are inherently OO based or rely on things like mutability. And I'd say if you're relying on these sorts of libraries, EF is a good example because, like, if you use state tracking, the way it works is, you hydrate an entity, you modify that entity, and then you just call update on the context, and it figures stuff out for you. That sort of stuff kind of doesn't play well with like the way F# is leading you down to work with immutable data, for example, and sort of stateless functions. That's one example, I would say. So that if you find yourself, and this goes back to Ian's point, where you're sort of banging your head against the wall and having to use like mutable operators and keywords everywhere in F#, that's either a sign that you're not using F# the way it's designed, or the libraries you're using don't lend themselves well to F#. There are examples like ASP.NET where there are wrappers around it, but there are some that just don't play that well. But in terms of like domains, I think something that helped F# in the early days, but not so much today, which is talking about like F# is a maths and sciencey thing. It's just a general purpose programming language. You can do web apps with it. We do all the time. You can write, there's not some specific thing that makes F# better or worse at in terms of, what type of business domain you're working in. You can write end-to-end apps. You can do console apps. You can do web apps. You can do analytics. It works relatively well for all of them. There are some areas that people tend to, I think, go down the F# path because that's areas where maybe C# hasn't had such a strong story in the past, like the analytical side. But that doesn't mean that F# is weak at the other areas as well. It's not a zero-sum game in that regard.
Everything we've covered today just makes me really, really want to go and do more stuff with it. But one of the problems I find is that every company I've worked for just does C#. So do you find that because of C# popularity, and especially, I guess, with C# becoming more functional too, is the F# community getting worried? Or I guess at the very start I hinted the fact I was doing more functional programming in C# made me want to learn F# even more. So maybe that's quite common, maybe it's not, I'm not sure. What's your experiences from the F# community side of things?
I would say in our experience as an F# consultancy, I'm not worried about that. I'm actually quite excited exactly for the reason you mentioned, Dan. It kind of removes a lot of the fear around some of these things. Like if I was to say to you now, F# has got great support for pattern matching, you probably already have a clue about what I'm talking about. Whereas if I'd have asked you 2 or 3 years ago, you might have been a bit more, what's this pattern matching thing? Or if I'd have talked about records, you now grok what those sorts of concepts are. It's more about just flipping the way that you work with them, where those become the default sort of structures you work with, rather than classes and structs and switch statements and if-then sort of thing. So it's not a worry for me. I quite like the idea that those sorts of concepts are losing the fear factor that they used to have a few years ago, whereas, you've got to learn all these crazy things that are really difficult to learn. Well, they're not that difficult. It's just different. And different can sometimes be scary or hard to grok, but they're not difficult concepts. It's more about throwing away, I think, some of the fundamental beliefs that we hold about how we model software. And I think that's something that C# is going through right now with things like pattern matching anyway. So for me, no, not a concern.
Hopefully it does drive more C# developers over to at least give F# a try. Do you find there's issues around recruitment as well? Because obviously with C# being more...
No. So I can speak personally from this. We get lots of people applying to us simply because we do F#. Yeah, and they're not. Most of the people we've taken on are not F# devs. They are C# devs that want to come and work with F#. There are a lot of people out there trying F# who just can't convince the company to use it, or are just not in a position to do it.
So I guess there you're saying from a hiring point of view, you've got lots of people wanting to try F#, so you've got lots of potential people looking for a job. But from the other side, if you're an F# developer wanting to look for a job, presumably there's a lot less positions to choose from.
Well, compared to C#, there definitely are, yeah.
I would say so, yeah. There is also, I was surprised over the last couple of years when we've been sort of going through recruiting rounds. We found what I would sort of call like dark matter devs, like people that are using F# in companies, and there are quite large companies and teams using F#, but they just don't advertise and talk about it as much. But I was sort of pleasantly surprised when I was like getting CVs from people that have got decent amounts of F# experience, years, but they've just done it in companies that don't take part in, Twitter and Slack and stuff like that. They're just happy doing stuff in the background, and that's great. But it's probably bigger than we think, but smaller than it's magnitude smaller than C# in terms of higher companies that are using F#. Of course, C# it's a massive community.
It'll be interesting to know if Microsoft have any stats against it.
Yeah, I think it is definitely, they do have stats, but they don't tell us what they are. But they basically, we know that it is, it's actually surprisingly big. It's probably hundreds of thousands of people, but it's not millions and billions of people, like C# is. But I would certainly, if you look at the downloads, Ironide, the Ironide plugin, which is the F# plugin for VS Code, that has about 100,000 downloads. I think, I don't know what the latest stats are, but it's, it's a lot. So it's not tiny either. There's one more thing I just wanted to say about people think that F# is really complicated to learn, and it does take. There's a bit of a learning curve, but Isaac can, I'm sure he would say that it doesn't take that long, and people, it's for some reason people are very worried about that compared with learning like Entity Framework is huge. And learning WPF or WCF, how many people remember learning WCF? There's these massive libraries out there which are really complicated to learn. And somehow a lot of companies will say, okay, well, that's fine. We'll send you on a training course or we'll buy you some books about it. And it's like, you don't say, oh, we can't use Entity Framework because it's too complicated. We'll just say, okay, we'll learn how to use it. And I think F# should really be in the same category. It's like, we think it's a lot of value. We'll buy some books about it. We'll do some go to some courses, something, and we'll learn it pretty quickly. I would say it's not any more complicated than any of the other C# libraries, but because it's somehow different, people are more scared of it.
Can you imagine going back as a beginner and learning C# now, and thinking how much you need to learn?
Not necessarily just C#, but object-oriented programming. It's kind of because a lot of developers learned initially from object-oriented programming. They've forgotten how much learning there was involved because now it's intrinsic in their minds. Where actually, if you erased all that knowledge from your brain and you were presented with functional programming like F# or object-oriented programming, which is going to be easier to learn after those two?
Right. People say that functional programming has all this jargon, but what about SOLID, which is 5 different acronyms, plus, you have IOC and you have TDD and you have polymorphism and abstraction, you have covariance and contravariance. It's like there's a lot of jargon, and then there's the hundreds of software patterns, the singleton pattern and the factory pattern and the visitor pattern and all that. It's very, very complicated. If anything, I would say that functional programming has a lot fewer patterns than traditional OO programming. There's like hundreds of patterns you have to memorize. In functional programming, there's maybe 10 things you need to memorize. There's just a lot fewer things you have to understand. I actually think it just seems funny when you're not used to it. But in fact, I think if you've done both, I think people who've learned functional programming would say is actually easier than OO in many ways.
I always find it funny, this is a bit of a tangent, but it's kind of like touching on what was just said about learning. With Git, I always find it quite funny that people spend ages learning Entity Framework, WCF, or whatever these things are, and then they expect not to have to learn Git, which they would use for all of these languages. It's like used by pretty much all developers, and things like rebasing and all these terms. People expect not to have to learn that, and it should just be really easy. And they don't spend any time. And then they spend lots of time and like learning one single JavaScript library.
It's funny that a lot of IT people, it's like, I got into IT and I don't really want to learn anything new. I mean, that's like, I don't think that really is a good attitude. There are quite a few people like that. And it's like, if you're in IT, stuff changes all the time. But I think there's a big difference between learning the latest JavaScript framework, which is going to be useful for about 6 months, maybe 6 weeks, and learning something like functional programming as a paradigm, which is going to be useful forever. And a lot of people say you learn functional programming, and even if you don't get an F# job, it changes the way you're programming in a good way. Most people say they're better programmers because they know this additional paradigm, And so if it's not F#, your C# code will be better. And if you switch to another language, it'll just be a very useful thing to know. And it's not like the latest JavaScript framework, which is, becomes irrelevant soon.
So we've obviously taken a few people on fairly recently, none of whom had done F# professionally. And they've been with us for 2 or 3 months. One's been with us for 6 months. And they learnt basically from scratch. And they're proficient writing professional code. In fact, they're writing professional code fairly quickly.
Are they from a .NET background?
Yes, they've come from C#.
Nice. I guess also it probably helps with job retention as well. Like, so if you've got a team and everyone's happy doing F#, and obviously as long as everyone's happy in the company itself, they're less likely to move on because they're quite happy doing F#, and there's less other places that do F#.
No, but for an employee, I mean, if you want to hire good people, asking people, people who are interested in learning new things, that's a good filter. If you get a lot of CVs or resumes from people, one way to filter out good people is like they're interested in learning new things, and if they're interested in learning F#, that's a great filter. And if they that's also a good way for as you're an employee. It's like a company that wants you to learn new things is probably going to be a better company to work at than a company that doesn't want you to learn new things.
I quite like the interview question about just asking what's on your list of things that you want to learn. Because quite often, like people that like to learn new things always have in their head, I want to learn all this, I want to learn this, I want to learn that. It's just I can't find the time. Most developers that want to learn have got this list in the back of their mind. Things they'll never find the time to do, but I think that's a really good indicator of like what you just mentioned, Scott.
Yeah, learning a functional language is definitely a good thing to do. Learning other ways of doing things. Learning Erlang as well. Looking at how they do things. That's a very different way of writing code. Yeah, again, it's not the syntax. It's the thought. It's the paradigm behind it.
So just to finish up on something that I mentioned at the very beginning, which is one of the first languages I learned was Smalltalk, which is like, if you want to learn OO, you need to learn Smalltalk because C# is not OO, I'm sorry. But I actually learned my first functional programming from Smalltalk because in Smalltalk, the collection classes are completely encapsulated. So the only way you can do something with a collection is to send it a function, a lambda. So if you want to loop over a collection, you have to pass in a lambda. And if you want to, change the collection, you have to pass in a lambda. And so Smalltalk is actually, in a funny sort of way, quite functional. I mean, a lot of the functional programming techniques actually equally well apply to a true functional language, like a true object-oriented language like Smalltalk. It uses many, many of the same techniques, which is kind of interesting.
Is there anything different from a testing point of view if you're writing unit tests or whatever kind of tests? I can't remember the term, but I remember listening to an F# talk and it mentioned a certain type of testing. Was it
property-based?
Property-based, that was it, yes. So what does that mean?
Scott, why don't you do this one? You've written enough blog posts.
Okay. So a property-based test is, imagine that most tests are what we call example-based tests. So if I want to test, I mean, let's say I have a little plus function that I've written and I want to test whether it works. I might say, well, if I pass in 2 and 2, I should get 4. And if I pass in 3 and 5, I should get 8, right? So it's like, if I pass in this, I should get this. But imagine that you were passing in random inputs. One of the problems when you pass in examples, you tend to stick with examples that you know are going to work. The classic thing is you never pass in weird strings. You always pass in simple strings. So you should really be passing in weird Unicode strings with line feeds in the middle and stuff, And we tend not to do that. But a randomly generated string would be much more likely to make your thing fail. So the problem is, if you're passing in random inputs, how can you even know what the right answer is? And so you have to start thinking about, what is your test trying to actually test? You can't just say, with this input, I expect to get this out. You have to say, for every possible input, what would be the right answer, right? And so you can't, for example, for addition, you can't say what the answer is going to be, but you can say that if you swap the 2 inputs, you still get the same answer. Like, the order of the inputs doesn't matter. So that's one of the things about addition, which is not true, for example, about subtraction. And you might say, well, if one of the inputs is increased by 1, then the answer is also increased by 1. Well, that's true for addition, but it's not true for multiplication. So you can come up with a bunch of what we call properties, which is true for any possible input. And that's what property-based testing is all about.
Yeah, if you want to try it out without using F#, but any language, is have a look at the diamond kata. So that basically says you build a diamond up of letters, of characters, and you describe what the diamond looked like compared to the input. So if you have an input of C, for instance, you get a diamond that goes A, B, C, B, A, building the diamond up, and a D would be, you'd have 4, you'd have obviously A, B, C, D. And you're trying to describe the diamond in terms of the properties of the diamond. So it's symmetrical, it goes in order, then it goes in reverse. So they're the properties of it. So that's worth looking at.
Can you send me a link so I can include that in the show notes?
Yep, I certainly can.
Nice. I'll have a play with that myself as well.
So aside from that, there are a lot of tests that we don't do because the type system stop a lot of them happening. So a lot of the null check tests, for instance, we don't do.
Yeah, and going back to that, when we try and not. This is one of the differences between C# and F#. Again, in F# you tend not to do defensive programming at all. You tend to assume that the parameters that have been passed in are accurate, and you normally have guarantees. Like, you guarantee they're not going to be null, because in F# they can't be null. But you also tend to create special types. If I want to have an email address and I want to guarantee that it has an @ sign in the email address, I would create a special email address type and have a special constructor for it that guarantees that if I have one of these things, it's going to have an @ sign. I never, ever have to validate it ever again. And because it's immutable, nobody can change it. So I would never just pass in a string and say this is an email address. I would probably have a special email address type. And because it's one line of code in F#, you tend to create a lot more of these little customized little small types than you would do in something like C#.
I used to be a massive TDD zealot, like in my C# days. The rest of the team used to hate me because I was like, everyone must do TDD. You must write tests before you code and stuff. When I went to F#, I kind of transitioned to more of a regression test sort of thing. I'll tend to write code. Maybe I'll test it in the REPL, make sure it works, and then I might write a test or two as a kind of regression to make sure if we do make changes in the future, we don't break any sort of behaviors that we've encoded in the current system. But I tend to steer away from TDD now. It doesn't really seem to give us too much value, particularly because, as Ian said, a lot of the times you tend to encode rules through types where you can, and things like pattern matching and discriminated unions give you a lot more confidence that you're dealing with all the different cases. And also, in terms of how you write tests, if you think about a lot of mocking libraries that you tend to use in C#, I called this method, does it then call this dependency? Or I called this method and did this property on the class change from 5 to 6? That you don't tend to use that in a functional world. It will be more like, here's some data, here's a function, I'll give that data to that function and I'll get a response back. Is the response what I expected? The end. It will really be more like that. Almost all your tests are like that. Create some data, call a function, you get some data back. Is the response what you expected?
So how does, looking at C# and mocking, I try not to mock too much, but I do use mocking libraries. And the main place I find I want to use it is if I've got a class that's calling into an external service. But even if it was calling into a database, I would spin that up in Docker and do an integration test rather than mocking. But if I've got a class that's actually doing an HTTP request into another service that's not part of this project, then that's the main bit I would try and mock. Presumably you still have that problem in F# though.
Yes and no. Again, I'm sure Ian and Scott have got some thoughts on this. So again, if you sort of adhere to kind of the ports and adapters style approach, you'll tend to test out your pure code and push those bits that are calling to the external service right to the edge. You may not even bother to test that code that actually calls those external services. It may be more that you call them and then it's the response that you're testing. How do I handle the response from one of these database calls? I've got a function that handles that response. Does it correctly handle X, Y, and Z sort of thing? Or you may want to do some mocking, but in F#, it may be rather than mocking a whole interface, you may just pass in a function that represents the call to the database rather than pass in an interface and mock the save customer call. It may just be passing a higher order function to my code that does that call to the database. And you can use interfaces. F#'s actually got pretty good support for effectively almost at the language level. It allows you to create mocks of interfaces without creating formal types. So you can say, give me a new IDB repository, and here's the implementation for the methods sort of thing, without having to create an actual type of fake DB sort of repository sort of thing. So it actually has some decent support for that, but it does tends to be on the edges of what we would normally do, I would say.
That's a really interesting point, like with interfaces and with C#, how you would use dependency injection quite a lot, presumably. And you mentioned high order functions. And I suppose we should step back and actually explain what that means for like C# developers that don't know. But am I right that it's just a function that takes another function?
Yeah, it's just like, select or where you pass in the function as a lambda.
And one of the nice things in F#, in C#, if you're passing in a function, you have to give it a type, and so you have to say it's a func with these two parameters. A func that takes an int and a string and returns a bool. So passing in functions can be kind of a little painful to write the code for. In F#, almost always we would not even bother to give it a type, and the compiler would figure out what the function was for us. So it's a lot easier, again, just in terms of ease of use. Passing in functions in F# is just so easy that you do it all the time. It's not a big deal.
That sounds really nice. So going back to my initial point about dependency injection, presumably you just don't need it in F#. So that's another pattern that goes away.
We can still use it. No, we still use it in Giraffe. You can still inject dependencies in. Still works exactly the same way. You can also inject functions as well, not just interfaces and classes. You've got to remember that F# still sits on the .NET framework or .NET Core, so it still has to be able to support all of those little things as well. So most of the time when they produce a new version of F#, it's not that they add new features to the language, although sometimes they do. The majority of the time it's to support new features in C# or support new features in the framework itself. Because obviously it's got to be compatible because it's designed to work in parallel.
Yeah, the F# language hasn't really changed in over 10 years.
So pretty much new versions are just supporting like changes in .NET.
There are still new features in it, to be fair, Scott. But then I would say,
yeah, there are a couple of tiny features.
But fundamental language changes.
They're not. Yeah, they're not huge. Yeah, correct. Yeah, I'd agree with that.
I mean, yeah, they've added a few things to computation expression stuff, but basically I can look at code from F#. Put it this way, the code I was writing 10 years ago would look very, very similar to the code I'd write today. And that would not be true for C#.
Nice. I'm kind of aware that I think the timer says an hour and 40 minutes, so this is becoming quite a long episode. But before we do wrap up, though, I know that Scott and Isaac have both written books. Do you want to do any plugging before we wrap up?
I've written a series of blog posts. I'm not an MVP. I'm not a book author, but I have written a series of blog posts which are on our company website. Basically, if you can work through those 12 episodes, those 12 blog posts, that's about 90% of what we do in our F# code. So the people that have applied to us have gone through the website, gone through the posts, and seen the sorts of things that we do. So if I had to do a plug, what I'd actually plug is I'd say I'd say two things. I'd say there are 3 awesome books in the F# community. One is Isaac's, so Get Programming in F#. Not doing this for, they are 3 awesome books. So Isaac's book, Scott's book, obviously, the Domain Modeling Made Functional. That's really good as well. And the other one is Kit Eason's Stylish F#, and that's really good as well. And that's like a slightly after Isaac's book. The other one I'd say, if you want to learn F#, there's two places to go. Number one, Scott's website, F# for Fun and Profit. And the other one is join the F# Software Foundation and join the Slack channel. There's a really good beginners section in there where people discuss and work through code.
I would say the F# community is really, really friendly. So if you're a beginner, don't feel intimidated. You can ask really kind of dumb questions and people will not get angry at you. They're very happy if you go and ask, questions like beginner questions. So people are very, very friendly.
Can I go in and say what's a monad?
You certainly can.
You can try.
You may not get people that know what it is.
It's not that important in F#. I mean, in Haskell, it's a big deal. You have to know, even to write hello world, you need to understand monads. But in F#, it's not such a big deal. So people don't go into it, don't make a big fuss over it the same way.
I'm probably wrong, but I kind of think I get it now. But I think Simon said it in the last episode, that once you understand it, you lose the ability to explain it. I don't know whether that's a common term.
It's a quote from somebody, isn't it? I can't remember who it is now. It's, one of the famous F#, one of the famous functional developers said it long ago.
Yeah, I think you can explain it. I think the problem is people try to explain it from a mathematical point of view, and it's the kind of thing where you don't understand what it is until you've had the kind of background of playing with lots of different patterns. It would be like trying to explain the visitor pattern to somebody, and they don't. It's like it's a certain commonality when you start writing things over and over in a certain way. You say, actually, you could extract this and call this a certain kind of thing. And monads are just another example of that. But you don't understand why they are. We don't understand what importance they are until you've actually had that experience.
From my understanding, and this might show that I completely don't understand them, but is it just a case of it's taking something and wrapping it in something else which abstracts functionality away? So, for example, the maybe type is abstracting away the fact that it could be nothing or it could be something. And then also you might have monads which abstract out exception handling.
Yep, you could.
Okay, so I'm going to say no.
Oh, I was going to say yes.
I know some people will say yes. I'm going to say no, because monad is a mathematical term. So what you're describing is just a data structure. Like it's just having a choice type with, success or failure, or a choice type with yes and no, maybe and missing and all that stuff. And async is you can have an async data structure which contains a callback function and so on. So that is actually not a monad. And so people call those things monads. It's just a data structure with some stuff in it. And that's why people make it overly complicated. So monad has a mathematical meaning, and I'm not going to get into it, but it's just it's a way of chaining these things together. It's a very common problem. You have a bunch of option types, you want to chain them together. You have a bunch of async types and you want to chain them together. You have a bunch of parser types or other things, and you want to chain them together. There's a technique for chaining them together, which is where monads are useful. But that's all I'm going to say.
Dan, just think of Elvis operator in C# and async await in C#. Those are both like specialist ways of dealing with some effect. I need to deal with async.
Yes.
I don't want to sort of do stuff every time, or I want to deal with nullability. I don't want to deal with it every time. If you can sort of derive the commonality between those two problems, that's like the crux of what I think of monads as is, really.
Yes, that's right.
And I'm not going to embarrass myself by trying to explain. I did one sort of user group, and I think people sort of understood, but it's not necessary.
It's not necessary at all to program F#. You do not need to understand monads. Absolutely.
Cool. So I said we were about wrapping up, but then I realised we haven't yet done dev tips. I think everyone here said they were up for doing a dev tip.
No.
No,
but go ask us anyway. Go on.
It's probably at the end. So I've got time to think of one.
Well, do you want me to do mine first then? So my dev tip is actually quite similar to one we've already had with Stuart Leeks from episode 7, where he basically said to question everything and really trying to understand why a change you've made in code actually works. Now, I had a Zoom call with an old friend the other day, and he asked me to help him with a code base he was working on, and he was new to this code base. And as we're looking through the changes, it quickly became apparent that he was changing it very much trial and error. He was new to the code base, and it was obviously he was just trying to change things until it worked and didn't really understand the bigger picture of the code base. Now, this isn't a dig at him, because this is something I see a lot, and it's something I've been guilty about in the past, basically rushing in and wanting to code without taking a step back. And I'm guessing a lot of our listeners can relate, because it is human nature. But this can be a really frustrating way of coding. So my tip is basically take a step back and spend time understanding the code before digging in. What are the existing design patterns? What was the intent that the previous developers had when building and architecting it? And spending that time up front can really make working with a code base a much more enjoyable, less frustrating experience.
Okay, so I've got a related code tip then, which is that it's actually the best kind of code is the code is not the important thing. So my tip is there's a very important difference between being efficient and being effective. So efficiency is like a light bulb, it's 5% or 10% more efficient what you're doing. Effective is doing the right thing. So there's no point being super efficient if you're going in the wrong direction. It's like having a very fast car versus being on a bicycle. If you're on a fast car, you're going in the wrong direction, the bicycle will still get you there faster because it's going in the right direction. And we spend a lot of time talking about efficiency and how many, velocity and story points and how quickly we can do these. Can we automate this process and so on and so on? Not that's a bad thing, but we really need to think, are we going in the right direction? And that's, to me, a lot about listening to people who aren't developers, listening and being empathetic, and not thinking that you have all the solutions. So that's my dev tip right there.
Nice. Very, very good point.
My dev tip, I'll do one quickly, is get plenty of sleep.
That's a good one. Very important. Absolutely.
That is a very good one. I remember years ago I read a book, what's his name? Why We Sleep by Matt Walker, I think his name was. And that is
that's good.
It's a life-changing book.
Yeah. You think you're being clever by trying to not sleep very much, but in fact you're just being you're being not effective.
One point he talks about is how when you're asleep, your brain is actually processing what you've learned. So by cutting down your sleep, you're not learning what you would be doing if you hadn't had proper sleep. So it's a really interesting book, and I'll definitely include that in the show notes. So great tip.
Yeah, I can highly recommend that book as well. My tip, I guess, would be along a similar vein to what the other guys have said, but don't get hung up on trying to solve every eventuality that might possibly happen N months or years down the line. There's always a kind of a sliding scale between solving the problems of today and maybe solving the problems of tomorrow. Focus on at least solving the problems of today and maybe for tomorrow, rather than today, tomorrow, and 5 years down the line. And the amount of times that I've written sort of solutions where it was a really cleverly architected and planned solution, but ultimately we never needed 75% of what we did. That's something that I try to learn and at least stick to now. You can't account for every eventuality. You will always end up doing something that ultimately you need to change in the future. That's just the nature of software and changing requirements.
Nice. I guess that's where the acronym YAGNI comes in. You're not going to need it.
Yeah, I think Sandy Metz, who's an OO programmer from Ruby World, I think, said, "Don't write code that guesses the future. Write code that adapts to the future when it arrives."
Nice. Maintainable code.
Much more succinct way of saying what I just said. Thank you.
That's why she's a wonderful developer.
A more functional way of saying it. Cool. So before we wrap up, does anyone have anything else you want to mention?
I would just say there's an awful lot of F# material out there for people who. There's a lot of beginner material, so don't be intimidated. And sometimes you have to read a lot of different blogs. Each person has a slightly different way of explaining things, so just keep reading blogs over and over until you're going to get the hang of it. But there's lots of good blogs like Ian just mentioned, and there's lots of good videos out there. There's good books. And there's the Slack F#. So yeah, don't be intimidated. It's a lot of fun getting into the F# world.
Yeah, it's probably the nicest community I've ever been part of.
Well, I'm going to go and join that Slack channel right after this recording. A big, massive thank you to our guests, Ian, Isaac, and Scott, and thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company, providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying this podcast, please do help me spread the word on social media. I normally use the hashtag #UnhandledException, and I can be found on Twitter at Dracan, Dracan, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And we will include links to all the things we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.